All right, let's talk about transformations. Let's say we have original function y equals f of x, and we're going to tweak the formula a little bit, and we are trying to figure out what happens to the resulting graph. All right, so for example, let's say c is a positive constant. If you add a positive constant to a function, what would happen to the graph? All right, you can see that since we're increasing the value of y by c, so the whole graph is going to move up by c unit. And the same thing happens if you subtract c. Of course, you're reducing the value of y, so it's going to go down by c units. So we have these transformation, shift up by c units and a shift down by c units. All right, so that's pretty intuitive. All right, next one. What if you add c or subtract c inside of parentheses? All right, so these are a little bit counterintuitive, but these are going to be a horizontal shift. When you add c, you are actually moving to the left, and if you subtract c, you're moving to the right, which are a little bit counterintuitive. Since you're adding c, you're actually moving the negative direction. Subtracting c, you're actually moving in the positive direction, right? So shift left by c units and a shift right by c units. All right, so number 2 is a little bit counterintuitive. All right, number 3 is pretty simple. What if you put a negative value in front of x? All right, what happens is all the y value gets negated, so which end up reflecting about the x-axis. Similarly, if you put the negative sign in front of x inside the parentheses, you're actually negating the x value, so therefore you are actually reflecting about the y-axis instead of the x-axis. All right, so I'm going to just put that in. All right, the next one, 4 and 5, we're going to assume that the c is greater than 1, so that there's no confusion between stretching and the compression. All right, so if you multiply a function by some number, constant bigger than 1, you can see that the y value is multiplied by that c. So it's going to get stretched vertically. If you divide by c, it's going to compress. So you're going to have a vertical compression, a vertical stretch by a factor of c, and a vertical compression by a factor of c. All right, and a c is going to be always greater than 1. Right? And similarly, if you do a multiply by c inside the parentheses, it's going to be a horizontal stretching and a horizontal compression. If you multiply x by c, it's going to be actually a horizontal compression. And if you divide by c, it's going to be a horizontal stretching. All right, so I'm going to write that down. All right. So let's see what happens to the picture using a software called Geogebra here. All right, so let's visualize this. All right, so I have a graph of square root of x. Let's add a number. Let's say we're going to add 2 to it. So f of x is plus 2. All right, so graph is going to look like that. All right, you can see that it's shifted up by 2 units. All right, so if you subtract, say, 2, right, you can see that it moves down by 2 units. All right, so these are very straightforward. All right, let's do let's say x plus 2 inside the parentheses. All right, you can see that you are moving to the left 2 units. If you do f of x minus 2, then you can see that you're moving to the right. Right, so these are a little bit counterintuitive. Right, how about reflection? Let's put the negative sign in front of f of x. Right, so you can see that it's reflected about the x-axis. If you put the negative sign inside x, you can see that it's reflected about the y-axis. Right, so it gets a little bit messy here. So I'm going to actually erase hide these guys so that we can see a little bit better. All right, then let's look at the stretching and compression. what would happen to the function if you multiply a function by, say, a 2? So it's a 2 times f of x, right? It's going to look like that. Can you see that all the y values get doubled, so it's stretched vertically, all right? If you do 1/2 times f of x, then you can see that everything, all the y value gets a half of the original value, so that it's vertically compressed. So it's a vertical compression by a factor of 2 in this case. All right, then we can do the same thing with the horizontal one. So I'm going to hide these pictures for now. All right, how about this? If you multiply x by 2, so you put 2x, right? So you can see that this is going to be, let's see, horizontally compressed, right? You can see that it's getting a half of the original value, right? Then if you do f of x over 2, if you divide by 2, it's actually, the picture gets horizontally stretched, right? So these are a little bit counterintuitive. You multiply by 2, it's a horizontal compression by a factor of c. If you divide by 2, you have a horizontal stretching by a factor of 2. So as you can see, whenever something happened horizontally, these are a little bit counterintuitive. Like adding c ended up going to the negative direction, which is to the left. And if you multiply by c, it's actually a compression instead of a stretch. All right, that's it. I hope that this was clear.